it, talk a bit about the things we are trying to do, our vision, and where we fit within the national vision, and where we hope to go with this. So what is Sunbird AI? So Sunbird AI is a non-profit, and our vision is sort of leadership in AI for social good. And why is it called Sunbird? So maybe I should explain this because people keep asking this. So the sunbird is a bird. There's a bird called the sunbird. So this is not two words sunbird, but there's a bird called the sunbird. And this is a small, colorful bird that appears in many countries in Africa. And so our ambitions are sort of tentacled like this little bird. So to really appear in different places in Africa. So wanted something that is African. This bird is mainly on the African continent. I think it's only on the African continent. And so want something contextualized in Africa and spread to the different places of Africa. And be colorful. That's why we have all these colors. We want to do things innovatively in a colorful manner. All right. So two key things. One, we want to use AI to generate evidence for policy. Because we think policy is the sustainable way to do practical AI, and also to contribute to AI policy. So the work we do generates evidence that contributes to how we do policy on AI in this context. So we have an eminent board of persons. I'm sure most of them are online. Most of them are not. Oh, we have one here. Professor Engineer Bainomjisha is one of our board members. So we have a diverse board of people who are from intergovernmental organizations, academia, and then private organizations. But the key focus is really on people who are skilled in policy, Africa, but also how to generate resources to fund this agenda. We have a diverse team. This is a Sunbird team. We are now 13 people. Mostly very young people. You've seen them presenting if you've gone to the demos. And a bit of identity, so leadership in AI for social good, and this idea of productization. So creating practical AI solutions. So the practical focus is quite important. So the practical focus means that one, we want to work with people who are contextualizing the problem. So we want to work with partners. If we're doing languages, we work with the Language Institute in Makerere. So people of the domain who understand the problem quite well. And leadership really means building systems that we can share. So we do open development. And we want to build systems that people can use and can grow, can add their knowledge, and they can grow these systems. And so this is what we really mean when we say leadership in AI for social good. And social good is, of course, very important. So we don't want to do things mainly for profit, but want to do things. We think AI has a unique advantage to influence the good of society. And why artificial intelligence? Well, artificial intelligence is a big thing, but also it's something we've done for quite a while that we know relatively quite well. But we see a lot of opportunities for sustainable development. This is the space with 4IR and everything, and particularly in improving planning and timely decision making. So these tend to be a source of many problems. How do you make evidence-informed decisions? And then strengthening this feedback loop. So we are citizen-based. We have a strong eagerness on citizens. So this feedback loop between citizens and the government that is doing a lot of the implementation, and then also informing policy. So we build evidence to inform policy. But also AI gives this unique advantage that you can leapfrog traditional constraints of infrastructure. That's why ICT and AI is such a big thing in the fourth industrial revolution. All right. Things we are intentional about, which I've already mentioned. One, social impact and policy. Two, collaboration with local organizations. So all the projects we do, we want them integrated in the local organizations that are dealing with the problems that are happening. So this is very important for us. practical focus, I've explained that, and clear client engagement. So we want products that are client facing, where the client is quite clear. So we do products at two levels. One, base products, where we build base artificial intelligence infrastructure and platforms that other people can build upon to build systems that can influence social good. But also, we build products that are client-facing, a very specific client, very specific product, very specific deliverables. So we really are keen on this practical aspect. And then open standards is key to what we are doing. And this idea of best projects, as I've talked about. All right, strategic outlook. We want to do a lot of things. I think this is the main goal of this slide. We really want to build the evidence for use of AI, right? So AI, unfortunately, or maybe fortunately, AI is a topic which is quite hyped, generally quite hyped all over. And really figuring out how to use it very well, or getting good evidence of how it's used, tends to be problematic. And we really want to see if we can build a portfolio of cases of projects that exemplify the use of AI for social good. So this is sort of our long-term vision. All right, the good part, projects. So what projects have we been doing of recent at Sunbird AI? So African language technology is one of those projects. We had a small demonstration here. And so there's been this big theme of leaving people behind, leave no one behind, right? And we think language in Africa particularly is a point where many people are left behind. So we have so much diversity in language in Africa. Even in Uganda alone, we have 43 languages that we know. And these are languages that are written and dialects, things that people speak, and they sort of burst even more than 43. And so people who can understand, who can consume content in English or sort of the main languages get left out. And we think this is an area in Uganda and in Africa that needs to be addressed. And so for this project, we started off by building the best technology. So collecting the language resource data. This means collecting language data that we can run computation over. So you collect it in a certain way, it's formatted in a certain way, and you can do compute over it. You can run algorithms over this data. And this is what the Sunbird Translate is. So we've done 3 products in this area. Sunbird Translate, which is the thing you saw there, and then Sunbird and the Soul database or dataset, which I'll explain a bit more. There's several use cases. I had some slides here, but I don't see them here. Okay, maybe I'll explain the use cases here. So there are several use cases for language technology. Some we've discussed with several people here, but things like agriculture. I know, for example, Dr. Joyce has been doing quite a lot of work in the Makerere AI lab with farmers, smallholder farmers. So farming is a big thing for Uganda and Africa. And a lot of the interventions, they are building digital tools for smallholder farmers. Digital tools that transmit information, or they have some automatic calculations that they're doing. And you get the sense that, language becomes very important in this area. You need things to be translated. You need things to be put in the languages that the farmers understand. So this is one good use case of language. Or things like call centers. During COVID, we saw this this was a big thing. People calling in from multiple places. Can you have a call center that has multiple languages? So the way to do that now is to have several people who know several languages at the call center. But translate, if you have good language technology, you can have automated translations. And this could be speech-to-speech translations, or speech-to-text, speech-to-translated text. There's several ways you could do this. Or fintech. We've been talking to our colleagues, our friends from IoTech that do fintech. So again, language is a big thing in fintech. You want the people who are left out the most, the unbanked people, You want them to access finance through technology, and sometimes language can be the biggest barrier to people accessing these services. And then many other things: automated document translation, tourism. There's several areas where there's almost no area where language translation or language is not a key thing. And so we're trying to build this platform of language that we can consume some of these services that are already available and are being built. All right. So I've talked quite a bit, so I'm going to invite someone from our team to come here, one of our engineers, so Lydia, to come here and just take us through what Sunbird Translate is. So Lydia.
Thank you, Ernest. Yes, we've been interacting outside there while doing the demos, and we've looked at Sunbird Translate and what it does. So here we have the regions that are covered by Sunbird Translate. So we have Acholi, Ateso, Luganda, Lugbara, and Runyankole, and we have some numbers here of how many speakers these languages have. So for example, you can see Luganda has 5.56 million and actually 1.47 million. So what this means is that these are some of the most spoken languages in Uganda, and we decided to represent them in our translation system. All right, so what is Sunbird Translate? This is a translation portal for text-to-text translation from and to English, also from and to 5 key Ugandan local languages, which I've already mentioned above. So here we just have a small picture of what Translate looks like. And let's have a small demo. I think some of you have already seen the demo from outside, but we can go through it again. So here we have the user interface for Sunbird Translate. We enter text, and then you choose the language to which you want to translate your text, and then your text will get translated. We have some sample phrases we use for people who just want to come and quickly test it out. Just click, see what it does, and go on. For now, I'm going to use some demo phrases because I don't want to take a lot of time typing, so I'll use a few demo phrases that I've prepared on the side. Let's start with a Luganda. Let's start with a Luganda phrase. Right. Sorry. So here I have to change the language to tell it to translate from local language first, then to English. So this says government ewadde ebibiina ebyobufuzi sente ezisukka mu buwumbi 13, and then it translates to English. The government has allocated over 13 billion Ugandan shillings to political parties. So we can also have it the other way around. We can have from English, so I'll change this section here. We'll go from English. So I'm picking sentences from current context, what's going on in Uganda at the moment. For example, commodity prices, as we've all seen happening recently. So let's first leave this in Acholi. I don't know if we have any Acholi speakers around here. They could help us verify. Anyone? Okay, we can move to we can move to Luganda, I think one of the most understood languages we have. So let's see, Ugandans prepare for hard times as commodity prices soar. Bannayuganda beetegekera ebiseera ebizibu ng'emiwendo gy'ebintu gyeyongera. That's quite good, right? Yeah. So what you can imagine this being is it can be a system that helps a lot of Ugandans to translate things from English or from local languages to either the local languages or English. For example, just until recently, we were not represented in the usual translating systems we find around, like Google Translate. And now only Luganda is represented. So this gives a chance to people who speak Ugandan languages to be able to translate their text. This can be used in so many different contexts, like Ernest has already talked about. So the representation we have here, for example, if we go to Runyankole, we can still get a translation. I don't know if we have people who speak that. They can also verify. You see that this could have it will provide us resources to also use our languages and to also communicate with people who are not able to speak English or even read English. So I believe this is a major step in representing Uganda and Africa as a whole in language technology, where we have been previously very underrepresented. Yes, so I think that will be it for me. Thank you, Ernest.
So yeah, and this again, so how this project was, there's a lot of collaboration with the Makerere AI Lab. So Dr. Joyce is here. Her team helped a lot with coordinating the translation with the Institute of Languages, getting translators. It's a huge process in trying to curate a good data set for these kinds of systems. All right, so we worked, so one other thing we did was Sunbird, which is an open source neural network model, machine learning model for analyzing social media posts. And we built this during the COVID pandemic. And the idea here was to try and understand the public perceptions on COVID messaging from the Ministry of Health and KCCA, working with Ministry of Health and KCCA. So there was a lot of confusion. COVID came with many terms that are not easily translatable. For example, quarantine, I mean, when you hear the Luganda songs, the quarantine. I don't know if that's the exact translation, but there are many terms in COVID that came about. And so we're trying to understand what's the messaging and how does the public perceive this messaging. And so this is a machine learning model that we've built that can easily be repurposed for analyzing social media text. So if you have social media text and you want to analyze certain things about perceptions of people on certain topics, then it's easy to retrain this model, which is published now, and then you have a quick system to work with. So this is so some feedback from the key teams. Again, working with local teams, contextual problems, this tends to be a key thing that we are keen on doing well. And then finally, for the African language technology, so we have published this data set, the data set that we use to do translate. So the biggest problem why there's not much technology around this is the data. So having a good data set, well curated, well packaged, that has been verified, several times by translators, people who know the local language, is key. So this data set, we call it the SALT data set. It's built in a sort of extensible way, so you can actually add other languages. So why this is important for Africa is that you can add several other languages very easily. African languages, local languages, or international languages, whichever. And we've provided sample models of how we built the technology, the language, how to extend the language, and all these are open source currently. All right, so the next steps, and this one of them is, the next step is really speech, and this is something the PS commented on in the demos outside. Speech is really a key thing. If you can translate from one spoken text to another spoken text, or one spoken text to text, a written text or translated text, this would be a key thing. And this is the next sort of thing we want to do. So this is a very, very hard problem to do, but this is why we want to do it here. We want to do hard problems here. Yeah. All right. Okay, so next project. So yeah, if you want to know more about this project, the demo is outside for Translate. The URL is there. You can try it yourself. Would really be keen for people to try it and give us feedback here, actually. So if you go to translate.sunbird.ai, really be good to give us feedback on how that is working. All right, the next project is environmental noise sensing. Noise is a significant, or noise pollution is a significant public health hazard. And so for cities like Kampala, where we are rapidly urbanizing, this is a real problem. You know, it has been identified outside, but we are taking a bit of time to identify it here. But I'm sure even you in your local communities where you stay, you know, there is a church, you know, that's in the neighborhood that springs out and wants to do, you know, overnight prayer on Wednesday, you know, all a bar or, you know, something nearby, or the street preacher, the herbalist nearby. All I could be making noise for you now, you know, there are many ways noise could happen. And we need to curb it. We need to control it. Okay, so we are trying to solve this by building a noise sensing system for cities. And so here's an example of an image. This is, I think, Kira Road, right there, the roundabout where they used to have that the Chigo in COVID, you know, where you couldn't pass. Anyway, so you have a lot of instances of noise, you know, sirens, street preachers, you know, borders, you know, motorcycle taxis, street vendors, street kids, you know, if you're in your car, it could be your spouse. There are many sources of noise that could could happen in this instance, but you know, we want to solve the ones which are environmental. So the World Health definition is noise sources with the exception of workplace noise. So that saves us from certain noises in the workplace. So the environment and noise is unwanted sound. And the key idea is exposure. So long-term exposure to noise has many effects, health hazards. So the key term there is long-term exposure. So if someone yells just now, or my talk is going to be short, so it won't, you know, I won't expose you too much. But this idea of exposure is important to measure. And this is what we're trying to do. And we're trying to do this by putting different sensors in different places and capturing noise. So why is this important? One, to understand the acoustic environment. Now we're getting some bit of noise there, but we're going to. So one is to understand the acoustic environment. So for planning purposes, if the city council, the government wants to put up a hospital, you want to take your kids to school, you want to shift to another house, you want to build a house in a certain area, wouldn't it be nice to have an example of the, you know, an idea of the acoustic landscape of that place? What are the noise patterns over time? Is there noise over the weekend, during the week? Is the noise mostly at night? Is it in the evening? Is it during the day? So this is information that this project can give, for example. And so you get these very interesting statistics, like, you know, X number of million health years are lost. In this case, for Europe, 1.6 million health years. This means healthy years for people who could be healthy and working are lost just because of noise, the irritation of noise, the psychological and psychosocial. That one. Okay, that word there. Yeah, these are the key health outcomes. So I want to invite one of our engineers, NASA, here to explain what we are doing practically with this project. So we have two sensors here, actually. They're measuring noise. And if you go to the demo, there is, you can see the noise in this room right now. But I'll invite NASA to come and explain a bit more about how we're doing this.
Thank you, Ernest. Yeah, so at Sunbird, after we found an opportunity to contribute to how we can fight noise pollution, we have developed our noise sensor. So majorly here is we analyze what noise is exactly in our community, and we then get physical with electronics, such that we can develop all the necessary circuitry which can do the noise measurement in our communities. So after we do measure the noise, then that's when we can translate that into the noise data that we are talking about. So for this particular slide, we've been able to develop that printed circuit board in black. And then because we want to ensure that whatever measurements that we are relaying from the communities where these have been deployed are accurate, then we definitely have to take them through a calibration phase. Yeah, because we do not want to just get sensors and we put them in the community and then we start to lie about the actual noise situation. Yeah, so after doing that, and this has passed our lab tests, we go ahead and assemble these, assemble them, burn our custom firmware that communicates with our Sunbird noise system. So we then start to get this data coming in, and as soon as the data comes in, it gets analyzed in real time. So to date, for the noise project, we have deployed in Entebbe municipality. So apparently Entebbe municipality has 4 wards, and for all the 4 wards, we've deployed 8 sensors there. Now, that there is the noise map, and this noise map gives us exactly what Ernest just talked about, the acoustic visualization in our communities. So now, by looking at that, you get to know that in this area, these people are currently having noise levels that are within this range. Yeah, so I'll go ahead and give you a demo of how we can analyze this. Yeah, so when we go to noise.sunbird.ai, what you see at the end of the day is the map of the world. Yeah, and you literally can come here and you select where we have deployed. So as we keep deploying, this list gets updated, so you can quickly zero down to an area of your interest. So for now, I'll take you first to Entebbe, and we see what's there, and then after we shall come back to Golden Tulip. Yeah, so in Entebbe, where there are 8, I will pull your attention first to this particular one here. This is in a place called Chigungu. So if you can look at this clearly, this is actually the runway at the airport, and then Chigungu is right here on the banks of the lake, on the lake shore. So you can click there and you would see that it's at 82 decibels as per right now, and this 82 decibels is presented to you after it has been analyzed. So how do we do this analysis? We want to get all the values for the last 30 minutes, and then we can tell you what is the least that these people have experienced. And for that particular location, as you can see, it is 83 decibels. Then we also tell you about the maximum that these people have been exposed to in that time frame, which is 101 decibels. Yeah, so that is not enough. You need to then go ahead and know the number of exceedances. So exceedances are the number of times these noise thresholds have gone above the recommended values that NEMA standards mention. Yeah, so on this page there, right, you can actually get a link to the NEMA documentation that indicates. But what it says is that the daytime threshold is at 60 decibels. So as long as you go past 60 decibels, then that is regarded actually as noise. And then we can start to track how much time you have been exposed to noise from the time that exceedancy happened, yeah, until then it can come down. And this limit does come down after when it is night time. NEMA defines nighttime as from 7 p.m. to 7 a.m. the next day. And the threshold there is 50 decibels. So the Sunbird noise portal then goes ahead to give you the chance to view this in a much better way, the graphical format. And for example, for this location, we can, let's say, maybe look at what the noise situation has been for the last maybe 1 month. And those there you see, that is the analysis. It will give you the averages at the respective times. So, and remember that we are doing this analysis in bits of 30 minutes. Yeah, you can then go ahead and maybe check out what it looks like today and how it was yesterday. Yeah, so we are deploying AI further for this particular project to go ahead and give you the actual evidence of what these noises are out there on the ground. So we want to tell you that you are exposed to 300 noises and they were coming from a church, or there were borders passing by and they were making that noise. We believe that that is the best way to evidence and give you actual data that can guide you in making the day-to-day decisions to regulate the noise. Yeah, so we are out there. You are free to come and check it out. The golden tulip, sorry. Yeah, so we can see this because perhaps you want to understand if we are making noise here. So we have deployed two sensors here. One is on this table here, and the other one is on the other table there. And yeah, so we literally can zoom in here, and we can see that yeah, this is sensor 1 at Victory Hall, Golden Tulip. And yeah, just before we came in, someone came for the demo and actually asked us, we want to see if the situation in the room is going to change. And before we came in for this presentation, the lowest people were exposed to was 29 decibels. And now you can see it has increased because there is a bit more activity happening at this time. Yeah, and from the time we've been here, we've been exposed to 5,847 noise exceedances. Yeah, so that gives you an actual visualization of the noise situation in this room where we are. Yeah, thank you very much. I hope that works out.
Thank you, Nasa. I was keen to know whether it's the high table there that's making noise or this one here, but I will not investigate further. Mm-hmm. So so this noise project, we are working with the mayor of Entebbe. So the mayor of Entebbe came and was like, no, we need to come and do this in Entebbe. Come and do the first demo in Entebbe. And he's very keen. He couldn't be here. I think he's out of the country somewhere. But he's very keen. He wants us to go next week. Let's go with the report. Let's go and look at the noise places and etc. So yeah, we are keen on really making this as practical as possible. And we're hoping to do this next in Kampala city here. So the next project is, so this one is a slightly different project, a very specific project, working with the GIZ and Fair Forward. I think Ivan is here. Oh, where is he? All right, he's gone out. Yeah, so here we're using machine learning and AI to help GIZ and the Ministry of Energy to optimize selection of target energy options, right? So mainly mini grids. So Uganda is very poorly electrified. We're like 20% electrified. It's very hard to understand because in Kampala there's many lights, but overall we are very poorly electrified. And so the goal is to figure out in which locations do you extend the hydro solar grid, which places do you put solar mini grids, in which places do you put solar home systems, and this kind of thing. And so the way we're doing this is using satellite imagery. So we're using a lot of data from satellite imagery, many statistics, nighttime lights, economic data, census data, raw imagery. So this, for example, is a village up north called Lamo. And this little village is called Agoro. The district is called Lamo. This is what it sort of looks like. And those green things, so using AI, you can try and classify where the buildings are. So buildings is one proxy again of what the situation is on the ground, for example. So the buildings sort of look like that, but you can zero in and see the buildings have different, they have different shapes. And then you can do further analysis, right? Okay, which buildings are permanent, which buildings are schools. So schools in the rural areas, and I suppose here have a very unique way they are formed. There's a field, all health centers, they form in a different way. And so you can calculate these statistics from satellite imagery. And then you can calculate many things. You can infer population index, economic index, infrastructure level, expected demand, and all these things. And then based on these types of data, then we can start positioning what types of things like energy options are available. So this is one very specific project, very specific client. But this can also be extended to any other thing. The parish model, for example, this one area that can make use of this type of analysis of satellite imagery. And then the last sort of thing we have is AI clinics, which we really want to launch. This is something we are very passionate about. When we started Sunbird, we were like, we need to do something like this. So we want to provide a relatively neutral source of advice, especially with regards to practical possibilities with AI. And this, we think there's a lot of there's a lot of goodwill on using AI to solve many things, on harnessing opportunities of AI. But then this sometimes gets lost in all the the hype, and we're going to do this and this, and we think there's a place for harnessing experience and knowledge to sort of give this neutral advice. So AI clinics, the way it works, you basically subscribe. If you have an organization, you want to try something on AI, you're doing something in fintech, or you're doing something in agriculture, you want to consult about a very specific thing in AI that you want to implement, you sign up for a 30-minute slot. It's purely neutral, not charged, and then we just discuss, okay, is it practical? What are the options? etc. This is sort of the idea of AI clinics, and can be for students, graduate students, organizations, startups that want to add AI, or any other organization. And then several other things we are doing.